Hello everyone, welcome to Wheatstone Bridge. Now before I move on to the principle of the Wheatstone Bridge, I have to tell you the resistances PQXR. Here P and Q are constant resistance and R is the variable and X is the unknown which we are going to find. Now here we can adjust the value of R using a rheostat or resistance box. So there's two conditions for this Wheatstone bridge: unbalanced and balanced. So at first, if there is a flow of current from, let's say, B to D, then it is called unbalanced condition. It can also flow from D to B. It depends on the potential difference between B and D. If the potential at B is greater than the potential at D, then the current flows there. If it is the opposite, then the current flows up. A small current called Ig, or the galvanometer current. Here we can change the value of R such that it reaches to a certain point that there is no flow of current from either B or D. Sorry, no, neither B nor D. So in this case, the potential at B will become the potential at D. So then it wouldn't require to flow some current to the galvanometer. In this case, Ig will be equals to 0. And here the principle now is P by Q is equals to X by R. This is called the principle of the Wheatstone bridge. Principle. Now of course we have to derive this principle to see where it came from. So let's use what we learned in the previous videos, Kirchhoff's laws. Now we know there are two junctions, so let's use the Kirchhoff's laws there. So we can use KCL at B. So here the current going in, which is I1, is equal to the current going out, which is I3 plus Ig. This is equation 1. Now again KCL at D, and again similarly I2 is equals to, here in fact Ig is coming from here, so the current going in is I2 plus Ig equals to I4, but I'll write the I4 right here. I4 is equals to I2 plus Ig. We're taking the case in which the potential of V is greater than the potential at D. And here we can now use Kirchhoff's second laws on the two loops. Now in this figure there are 3 loops, but we only have to take 2 loops to derive the relation. So here let's take this loop ADBA, and another, let's take the other half BDCB. So using KVL at or for ADBA, here the EMF for this loop is in fact 0 because there is no EMF flowing for ADBA, which is equals to, here we have to use the anti-clockwise and clockwise sign convention. So here the current I1, it is actually going clockwise, right? So it is minus I1 P, because the here resistance is P, and here Ig is also negative, so Ig G, because here I forgot to mention that the galvanometer has a resistance of its own, because it is a low resistance device. And here I2 is going anti-clockwise, so it is I2X. And here we can clean up a bit, make it all positive, so I1P plus IgG is equals to I2X, equation 3. Now again we can use KVL at the second loop BDCB. We get 0 is equals to, here if we're taking this loop, then this is anti-clockwise, so IgG plus, and here 0 because of the same reason, right? And here again I4, that is still positive, so I4R, and here I3, now that's going clockwise, so we should take it as negative, so I3Q, so we have I3Q is equals to IgG plus I4R equals, equation 4. Now we took this case when Vd was greater than Vd, that means this was for unbalanced condition. Now what we do is we take balanced condition by changing the value of R, because this is variable resistance. Now let's say the value of R is adjusted such that we reach balanced condition. So we reach balanced condition, and here that means there will be no current flowing through Ig, so that means Ig equals to 0. Now if Ig equals to 0, all of these equations will be very simple. So here for first one, I1 will be equals to I3, and here I4 will be equals to I2, and again we can use this equation 3. So at equation 3 we will have I1P equals to I2X, and again from equation 4 I'll write from 3, and also we'll have I3Q is equals to I4R. This is from 4. Now what we'll do is simply divide this by that. So that means we get I1P by I3Q is equals to I2X by I4R. Now using I1 equals to I3 and I4 equals to I2, we can see that these two cancels and these two cancels. Therefore we have P by Q is equals to X by R at balanced condition. This is the principle of Wheatstone bridge. If you learned something new, please like and subscribe. Thank you.